welcome to today's edition of our training. Today, we'll continue with where we ended last 2 days. We ended at memory measurement, the memory measurement. And so we started by saying that the bit is the smallest memory measurement in measuring data in the computer system. So it followed by the byte, then we have the kilobyte, then the megabytes, then the gigabytes, then the terabyte. Okay. We also learned that 8-bit is equivalent to 1 byte. And you know what a bit is. A bit is just like saying a character. A bit is equivalent to a character. So that if you have one bit, it is equivalent to 1 character. Okay. A moment, let me do this illustration on the screen for you to see. So if you have 1 bit, it's equivalent to 1 character. Two bits is equivalent to 2 characters. 3 bits is equivalent to 3 characters. Okay, so yeah, let's have an example of a character, the 1 bit. 1 bit is like a is a character. Example of a 2-bit word is like saying is. An example of a 3-bit is like saying and. Okay. So 8-bit So 8-bit is equivalent to 8 characters. Okay. Now, 8-bit is equivalent to 8 characters, and it's equivalent to 1 byte. So when you get to when your characters are up to 8, you no longer say 8-bit again, but rather you use 1 byte. So an example of 8-bit character is, let's say, documents, UCUNENT, 1, 2, 3, 4, 5, 6, 7, 8. Yes. I hope you understand. Now, we now know how many bits is equivalent to 1 byte. Now, 1024 bytes is equivalent to 1 kilobyte. Okay. Now, 1024 kilobytes is equivalent to 1 megabyte. One 1024 megabytes is equivalent to 1 gigabyte. And then 1024 gigabytes is equivalent to 1 terabyte. I hope you understand. And so some of you would say, I have 1 gig or 1 gigabyte of memory space. It is actually, when you say you have 1 gigabyte memory space, you have actually truncated, or you have actually approximated it from the original size, which is 1024. I hope you understand. So it's not an exact value. Now, I'm going to write a statement on the screen. Comfort, you are online. Jifa, you are online. And then Judith, you are online. You will tell me the number of characters that exist, or you can see in this statement. The statement is, I am learning. Okay, I am in class. I am in class. So I'll start with Jifa. Jifa, can you hear me? If you can hear me, unmute your screen.
Yeah,
Yes.
I can hear you.
Okay, so I am in class. How many characters can you see here?
10.
Okay. So you say 10. Jifa says 10, eh? Okay, Jifa. Let's hear from Comfort. Comfort, how many characters can you see here? Let me make it bigger for you to see very well. So how many characters can you see in this writing? You also say 10.
Or technically, it's 10, but you can say it's more than 1 byte. So I don't know how
Okay.
you say that.
Okay. We'll come to the number of bytes that you have there. Okay, Judith, can you hear me? Unmute and then tell us the number of characters you have here.
Yeah, it's 10.
Judith also says it's 10. So you all are wrong. I know. I know you'll be surprised.
Hey.
I know you'll be surprised why I'm saying you are wrong. Now, in digital systems, you can unmute yourselves now. In digital systems, spaces and punctuations are considered as characters. Never forget. In digital systems, spaces, punctuations like comma, dot, question mark, you know all the punctuations. All those punctuations are also considered as characters. So in this case, I am going to count. Then you realize that I'm correct. I have about 13 characters here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I have 13 characters in all. Now, I'm going to ask you another question again. How many characters do I have here? In the second one, this very one that I've highlighted, how many characters do you have? So I start with Judith. Okay, Jafar is already online. So Jafar, answer us.
It would be 14.
14. Judith, do you agree with her?
Yes, I agree.
Okay. What about Comfort? Comfort, do you also agree?
Yes, please.
You agree. Okay, that is fine. So this time you are all correct. Now that you've gotten the concept of how to count characters in the computer, now let's see how we are going to, how it will be saved in the computer. You realize that I was telling you, when your characters are up to 8 bits, okay, it is equivalent to 1 byte. Now, if your characters are not up to 8, but you decide to save the document in the computer, the system or the operating system automatically truncates it or run it off to 8. I repeat, if your characters are not up to 8 and you decide to save it in the computer system, the computer or the operating system automatically truncates it to 8. So that if I have something like this, I am has about 4 characters, right? 1, 2, 3, 4. 4 characters. I decide to save I am alone in the system. Technically, you are supposed to tell me that it is 4 bits. Am I right? But so long as you are saving it in the system automatically truncates it to 8 bits. Okay. The same way, if I should continue, I am in. So I have 1, 2, 3, 4, 5, 6, 7. I have 7 characters. I have 7 characters. Okay. It is still not up to 8. Still, the computer would truncate it to be 8. Is it not a cheat? So if I have 4 characters, the system sees it at as 8 bits. If I have 7 characters, it's still 8 bits. So you realize that the way you save data on your computer also counts on how fast your drive gets full. I hope you understand. If you are not able to utilize the spaces, you are not able to utilize the space on your computer very well, you realize that in a short while, your system gets full. Okay, so now let's convert this into the memory measurement. So now I have 1, 2, 3, 4, 5, 6, 7, 8. So up to here, up to this particular portion, the system saves it as 1 byte. Sorry, 1 bit. 8 bits, which is equivalent to 1 byte. Okay. So the system is going to save this side too in a different cluster. So let's say 1, 2, 3, 4, 5. So I have a total of 1 byte, 8 bits. 1 byte, 8 bits makes up these characters. 1 byte, 8 bits. Am I clear or I'm confusing someone? Connie? Do you understand?
Please, I'm not clear. Judith.
You are not clear. Judith, you are not clear. Okay, let me go by again.
Yes.
Okay, so now this is how it goes. We were saying that when you come here, let me go up a bit. 1 bit is equivalent to 1 character. Okay, and a bit is the minimum memory measurement in the computer system. So if 1 bit is equivalent to 1 character, what at all is a bit? A bit is just a character in a character you enter in the system. So a character is any alphabet or any number or any symbol, any exclamation you enter in the system. So long as it's just 1, then it means that it is a bit. So we have an example of a bit here as a. It's an example of a bit. Do you understand? 2 bits is equivalent to 2 characters. Okay. So an example of 2 characters is is. We choose is as an example of 2 characters. You can also choose on as an example of a 2 character or a 2 bit. Okay. In is also another example of a 2 bit or a 2 character. 3 bits is equivalent to 3 characters. 3 bits is equivalent to 3 characters. We have end, there. Okay. She is an example of 3 characters. Even the 2 characters, we can even have he as an example of 2 characters. With this understanding, now let's move here. Now, the same applies to 4 bits is equivalent to 4 characters, 5 bits is equivalent to 5 characters, 6 bits equivalent to 6 characters, 7 bits equivalent to 7 characters, 8 bits is equivalent to 8 characters. 8 bits is equivalent to 8 characters. But then, when you get to, when the characters are up to 8, this time round, you don't say 8 bits any longer, but use byte, which is the next memory measurement after bit. Okay, after bit, the next memory measurement is byte. So you don't say 8 bits any longer, but you say 1 byte, which means that 8 bits of characters is equivalent to 1 byte. 8 bits of characters is equivalent to 1 byte. So we gave an example of a character that is 8, and we said document is a perfect example of a character that is 8, because when you count the characters, 1, 2, 3, 4, 5, 6, 7, 8, it amounts to 8. So this time, if you are only saving the word document on the computer, just that, you open a document, maybe a word processing document, and you just type the document, then you decide to save. The system would save it as 1 byte and not 8 bits. It will not use the bit, it will use the byte. Do you understand? Okay. Now, we also realize that, okay, before I come to the next memory measurement, let's now jump from this side, okay, and solve this particular problem here. Now, the problem here is that we later realized that when you are saving data in the computer system, the character and the spaces and the symbols you use are all counted as 1. They are all counted together. So for instance, technically, you realize that I asked you a question. How many characters are in this? For mine, it was like this. Let me take off this one. Oh, which one was that? Was it this one? I am in class. And you all said there were 10 characters. Technically, you were right. Because when you count the number of characters, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You have 10 characters. But then I later told you that spaces are part of the characters. Spaces are part of the characters. So when you are counting the characters, you must include the spaces. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So in this statement, you have 13 characters, technically. In this statement here, we have included the full stop. So that makes it 14 characters. I hope you understand. Okay. Now, we want to convert this into what? Bit and byte. So from this scenario we had here, this perfect scenario, we said 8 bits is equivalent to 8 characters. And that is equivalent to 1 byte. Okay. Now, when you bring this scenario, you want to bring this scenario to fix this statement here. It means that you are going to have 1, 2, 3, 4, 5, 6, 7, 8. So I am in alone is 1 byte. I am in alone is 1 byte. Now, so let me say this one here. Let me see if I can get some color to color it. Do I have color here? Fonts. Unfortunately, I don't have, okay, show more fonts. No, I don't have colors to color this in Notepad. I don't have colors. Don't worry. So I am in is 8 characters or 8 bits, which is equivalent to 1 byte. Now, I will continue from where it ended at 8. So I'm continuing from here. 1, 2, 3, 4, 5, 6. So I have, in this statement here, I have 1 byte, 6 bits. 1 byte, 6 bits. So this is equivalent to 1 byte, 6 bits. The system is still going to save it as how many bytes? Who can tell me? Jifa, can you tell us how many bytes will it be saved in the computer?
Two.
See, very good, very good, very, very, very good. Judith, kindly unmute.
Please come again.
Say that again.
Come again. Question number 2.
The question, what I was saying is that I have not asked you a question, Judith. Or is it comfort?
It's comfort. Yeah.
Okay, comfort. What I was saying is that after saving this in the system, okay, when we were doing the calculation, we realized that the total memory measurements here will be 1 byte, 6 bits. Okay, then the question is, when you save it in the system, how will the system save it? Or how many bytes or bits will the system save it? Then Jifa said it is 2 bytes. Do you agree with her?
Yeah.
Okay, so why do you agree?
Because the system will run the 6 bits into 8, and 8
Very
is 1.
good. Very good. Very good. I now like the way you have understood this particular concept. Judith, are you there? Judith, are you there?
Hello. Hello.
Yeah, are you there?
Yes, yes, yes. The line
Yeah.
is breaking back.
Okay. So do you understand the concept now?
Yes, I'm getting it.
Okay. Okay. That is wonderful. That is wonderful. So with this, you are telling me you all agree with me, say it is 2 bytes. The system will save it as 2 bytes. Now, How many bytes will the system save this one? I am in class, full stop. How many bytes will the system save it? How many bytes? Connie, can you answer us? How many bytes?
Still
Hello? Hello, how many bytes?
two.
Still 2. It's still 2 because we are going to get 1 byte.
Still 2.
Yes, yes, you are correct. 1 byte, 7 bits, because the dot has been added to the statement, and the system is still going to see it as 2 bytes. Now, look at this one. I, I'm in class. Judith, how many characters will it save it? Or how many bits or bytes will it save it?
It's 15.
How many?
15. 15 bytes.
No.
Sorry, 15 characters.
15 characters. So when you truncate it, it's going to be how many? It's not 15 characters. So I show this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We are right, 15. So how many bits is it going to save it? Bits and bytes. So let's say this 1, 2, 3, 4, 5, 6, 7, 8. So it ends here. Okay, am I right? 1, 2, 3, 4, 5, 6, 7, 8. It ends here as 1 byte. Then we have 1, 2, 3, 4, 5, 6, 7. I think we have omitted 1 character.
I talk, please.
Say that again. Say that again. Hello? Hello? Okay, so let me see. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. This 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. So this rather 5 here. This is 5. This is 6. So this is 7. So this is the correct way. This is the correct way it will be. Do you understand? Okay. Having a clear overview of how this works. Now, 1024 bytes. So that means that I know by this time you will not say the 1024 bytes is equivalent to 1024 bits or characters. Because you know 1 byte is equivalent to 8 bits. So if you want to get the number of bytes in a number of bits in a byte, you are going to multiply 1024 by 8, and that will give you for the kilobyte. I hope you understand. And so 1024 kilobytes is also giving you 1 megabyte. Then 1024 megabytes is giving you 1 gigabyte. Then 1024 gigabytes is giving you 1 terabyte. Why the difference is from the bit to the byte. Now that we have taken our time to go through it and you've understood the concept, then I think it's just a multiplication of what? 1024. So if you have a data worth 4 gig, 10 gig of data, or 10 megabytes of data, you should know the number or an answer, the characters that are involved. Are you aware that images also form a certain bit, a certain amount of characters using the pixels? You see the dot, that forms the images. I hope you understand. So all those things forms part of the characters that are in the images. I hope you understand. That is why images and then videos are usually heavier than the normal characters. So you can have a video, one single video with so many office documents, but the video weighs more than the document because of the weight. Sometimes the voice in the video also makes it carry so much weight. Any question? Any question? Any question so far? Okay. With the rest of the time, let's look at our next topic. I'm going to, or the next lesson, the information processing cycle. The information processing cycle. Now, what is information? What is information? What is information? Judith, can you tell us what an information is?
Hello.
Yes.
Okay, so
yeah.
an information is providing something like a fact or learning about something.
Okay. Okay. You are right. Connie, what is an information?
Process data.
An information is a processed data. An information is a processed data. All your answers are correct. All your answers are correct. Now, this that we have done, we're trying to gather some facts right now. So long as we save it into the computer per byte, it now becomes an information. Because you don't save unwanted stuffs on your computer. You save it with a rationale or with the reason of retrieving it later in the future. You understand? So in your computer, anything that you think it is not needed, you try to scrub it off. You think it's no more required in the future, you delete them. But everything you would need in the future, you save it in the computer and it becomes an information to you. It becomes an information to you and to other people who may also need it, especially when you are connected, you have connected your computer onto the internet. I hope you understand. So everyone can create or everyone can gather data. And when you process your data and you share, then it becomes an information to other people. When you share your information, when you share your data, it becomes an information to other people. Now, we are going to look at the stages through which data passes through to get, before we can get an information. Before we can enter data into the computer system, you need devices we call the input devices. You need devices we call the input devices. And so input devices accept data from the user. The input devices accept data from the user. In the computer system, you know, we have the basic computer components are the keyboard, the mouse, the system unit, and then the monitor. The keyboard, the mouse, the system unit, and then the monitor. These are the basic components of the computer system. Now, when you want to look at the laptop, the monitor is attached to the system unit. The keyboard is also attached to the system unit. The mouse is also attached to the system unit. So the part that you put on your lap, you understand, contains the keyboard, the mouse, and the system unit. The monitor is the part that you view your information from on the screen. So the screen area is the monitor. I hope you get it. Okay, so the system understands or takes feedback from you through the input devices. Now, what are the input devices? The input devices are devices that accept data from the user. So an example of an input device is the keyboard. The keyboard, because you use the keyboard to type data into the computer system. So if the data is coming from the user entering into the computer, all the devices that we look at are input devices. All the devices that we look at are input devices. So another input device that you can talk about here is the mouse. The mouse. The user uses the mouse to instruct the computer. So data is coming from the user into the computer. That is why we say they are input devices. I hope you understand. Now, another example of an input device is the webcam. The webcam, the camera that is placed on the screen. That captures your image into the computer. It's also another form of what? Input device.